Hello guys and welcome. In this lecture we'll see how to build an application that Cartonify Images. We will give it an image and it will give us the edges of these images and the cartonified image of this original image. So let's start. So first I will create a Python file. I will call it Cartonify Images.py. I will start by importing CV2 and numpy as np, and I will read this image cv2.imread data, and I will read the Obama image. So this is a big image. We can resize it to make the processing faster and easier. So I will take the height, the width, and I don't care about the channels of the images, and then I will call the image.shape, take them, and then I will say image equals to cv2.resize the image, and I will give it integer of the width times 0.4 to take just 40% of the width, and also let's make this in parentheses, and also int of height times 0.4 to take just 40% of both width and height. And I will show the image here, cv2.imshow original and image, and then cv2.weightkey 0. Let's run this code and see the image, Cartonify Images. So this is the original image, as you can see it here. Now we need to create a grayscale image. So gray cv2.cvt color of that image, and call cv2.color from BGR to gray. And then we need to get to blur this image and then get the edges of this image. I will first create a blur image of this grayscale cv2. I will use the medium blur of that gray and give it a kernel size of 7, for example. And then I will use adaptive thresholding to get the edges of these images. So I will call them edges cv2.adaptive threshold, and I will give it this blurred image and a max value of 255, and the adaptive method I will use cv2.adaptive. I will use the mean adaptive threshold Gaussian. I want the adaptive threshold mean, so adaptive threshold mean, and for the threshold type I will use cv2.binary threshold binary, and the block size I will choose 9 and the C as 2. Then I will make, so the result image will be cv2.bitwise and between the original image, the image and itself, using these edges as mask. So mask is these edges. Let's show them here. So first I will show the edges, cv2.imshow edges, and call them here edges, and cv2.imshow and the result image, or the cartonified image. So the result image. Let's run the code here. So this is the result image, and these are the edges here and the original image here. We can of course modify the type of change here, the type of blurring, and adjust also the kernel size and also the block size of the adaptive threshold, and the C here we can also adjust it. So for that I can create a trackbar and use it for adjusting these values and choose and make the user able to choose the appropriate value of the block size and also the kernel size. Let me create a trackbar here. So I will create here def nothing function that just take x and its pass, and I will create cv2.named window. I will call it trackbar, and then I will create cv2.create trackbar. I will give it kernel size as a name and this trackbar window, and I want it to be the default value to be 7, for example, and the max value to be 100. And using this nothing function, I will copy this one and paste it here. I will change this to, for example, I want to change the block size here. I can make it block size and just say b size, and I can make it also change from 7 to 100, the same here. So the code will be changed from here. So for that I will say while true, and then I will get this key size as cv2.get trackbar position, get trackbar position. I will give it this variables here, or these names here, the name of the trackbar and the name of the window, and I will copy this and paste it here. So here I will use b size and here b size. We need these key size and b size to be odd numbers, so I will check that, and if they are not, I will add one. So if key size is not an odd number, means that the rest of the division on 2 is equal to 0, then key size will be incremented by 1, and the same also for b size. And then b size will be incremented by 1. Let's make this in this while loop, and then I will put here the key size and here the b size, and now we can change, we need to change this to b if this one waited for 1 second is equals to order q, then break the loop, and also cv2 dot destroy all windows if we close these windows. So now we can run the codes. I think it is ready. We can also print here the value of the b size and key size on the image. So cv2 dot put text on the resulted image, and I will use the text as, so key size as like that, and saying string of key size, and I will use this one to say b size is equals to string of the b size, and then we need to give it an origin. So I will give it, like, for example, 20 and 50, and then the fonts I will choose cv2.font Hershey simplex font Hershey, or you can yes simplex here, and the font size I will use 1, the color as, for example, 0 to 155 to be green, and the thickness as 2. Now we are ready to run the code, and I can come here, so I will close this and run the code. So this is the resulted images, and we can change the kernel size and the block size from here. So if I change the kernel size, it can be like that. If I change the B size, it can be like that. It is better to choose small numbers. In that case, if I make this lower, we can also apply it on another image. For example, if I give it an image here, it's called Elon, and if I comment this because it is a small image, I run the code here. So this is the image of Elon, the edges here, and the original image here. So let me choose this like that, and I will get trackbar here. And if I change it like that, so you can see the image here. You can see the edged image and the cartonified image. You can adjust these numbers. Even you can apply it on other type of images. So I have an image here, dog, for example. If we show it here, size, edges, original image, the trackbar. If I change the values, you can see the results.